Hello everyone, we are group J and today we are going to solve exercise 2.40, which deals with acceptance, sampling and normally distributed measurements. The context is a soft drink company whose bottles must withstand internal pressure. Bottles with 2 liter resistance are considered effective. The resistance of the bottle follows a normal distribution with mean 257.9 grams, standard deviation 42 grams per centimeter, and a bottle is considered effective if its resistance is below 225 grams per centimeter. In exercise A, we have to obtain the probability that a bottle manufactured by a company is defective. We know that this is a normal distribution because in the statement it is said that the resistance to internal pressure of a soft drink bottle manufactured by a company is normally distributed. We also know that the variables are independent, so now we are going to R Commander to solve it. So we have the variable X is the resistance to internal pressure of a soft drink bottle, so X follows a normal distribution that the average is 257.9 and the standard deviation is 20.
Part A, we are told to obtain the probability that a bottle manufactured by a company is defective. And as we can see in the statement, this happens when the resistance is less than 225 grams per square centimeter. So to calculate this, we go to distributions. It is a continuous distribution and a normal distribution because it is told in the statement. We go to normal probabilities. The variable value is 225, while the mean is 257.9. This data is all appears in the statement, and the standard deviation is 20 with a lower tail. And as we can see, the result is approximately 0.05. In part B, we want to obtain the probability that a lot of bottles is accepted, taking into account that 50 bottles from the lot are extracted, and it will be the lot of bottles will be accepted if no more than one is defective. So first of all, we have to define D as the number of defective bottles from the lot, and to obtain the probability that we are looking for, we have to look for the probability of D being less or equal than 1. So using R Commander, we obtain that the probability that we are looking for is 27.96%. In part B, we want to obtain the probability that a lot of bottles is accepted. This happens when if extracting 50 bottles from the lot, no more than one is defective. So to obtain this, we have to go to binomial distributions and put this number. The variable value is 1. The binomial trials, as it is said in the statement, is 50, and the probability of success is 0.05. The result is 0.2794.
Letter C, we have another acceptance criterion, where the company extracts 15 bottles from the lot, and if all of them are non-defective, the lot is accepted. If 2 or more bottles are defective, the lot is rejected. And if there is only one defective bottle, another 15 bottles are extracted, being the lot accepted if none of them are defective. They ask us about the percentage of lots that will be accepted. Okay, we know that 15 bottles are extracted. Here, D1 is the number of defective bottles in the first extraction, and D2 is equal to the defective bottles in the second extraction. D1 and D2 are independent because it is true that we need to know the defective bottles in the first extraction in order to have D2 observed and the second extraction observed. But the result of D1 does not influence the number of defective bottles in D2. So here D1 is equal to 0, the lot is accepted. If D1 is higher or equal to 2, the lot is rejected. And if D1 is equal to 1, there is another extraction, D2. If D2 is equal to 0, the lot is accepted. If D2 is higher than 0, it is rejected. So here it follows a binomial distribution. The number of trials is 15 and the probability of being effective is 0.05. We know that it is binomial because there is the same probability for every bottle to be defective. So now with our commander we know that the probability of D1 equal to 0 is 0.4633. The probability of D1 equal to 1 is 0.3655. And the probability of D2 equal to 0 is 0.4633. So to do the probability of accept, that is the probability of the acceptance, we have to do the sum of probability D1 equal to 0 plus the probability of D1 equal to 1 multiplied by the probability of D2 equal to 0. So we do it with numbers and we have that the probability of acceptance is 0.6329. This means that with this extraction criterion, the 63.29% of the lots will be accepted. Another acceptance criterion where the company makes an alternative proposal. 15 bottles are extracted from the lot. If all of them are non-defective, the lot is accepted. If 2 or more bottles are defective, the lot is rejected. And if there is only one defective, another 15 bottles are extracted. And the lot will be accepted if none of them is defective. We want to know which percentage of lots will be accepted. So what we are going to do is to take the probability of all the defective bottles with the binomial probabilities, being the binomial Trojan's 15 and the probability of success 0.05. Here we have, and we can see that the probability will be this 0 and the probability of being 1 will be this. So to have it with the appropriate numbers, what we are going to do is to take this, we copy and put here, and we click enter or submit, and we will have here the probability with rational numbers. We are going to do the same with the probability of one bottle defective. We put it here and click submit. And to take the probability altogether, we have to do 0.46 plus 0.46 multiplied by 0.36. We are going to do it in another RGUI like this, and we will have that the result will be 0.6327.
exercise D proposes an alternative criterion where some bottles are randomly extracted from the lot until the first defective bottle appears. If 30 bottles have been extracted and no one is defective, the lot is affected, and otherwise is rejected. With that said, we know that this is going to be a geometric distribution since X is equal to the number of failures obtained by performing a succession of Bernoulli experiments before obtaining the first success. So this follows a geometric distribution where X must be 30 and the probability is 0.05. Now we are going to go to R Commander to solve this.
To solve part D, we know that 30 bottles are selected, and if exactly 0 bottles are defective, the lot will be accepted, and that's what we are looking for. By doing this, we select distribution, discrete distributions, binomial, and we click binomial tail probabilities. The variable value is 0, while the binomial trails, we know that there are 30 bottles, and the probability of success is 0.05. Well, 0.05. Lower tail, and we have the result, which is 0.2147.
Now that we checked all the possible options, we can decide which one is better and solve exercise E. The company should choose the criteria C as it allows to accept the most number of lots with a 73.29%.